Hi, everyone. I'm Rachi Singh. I'm a researcher at Microsoft, and soon I'll be starting as an assistant professor of computer science at Cornell. In this video, I'll give you a preview into the wide area networking session at SIGCOMM' 2022. Let me begin with a brief overview of wide area networks. Wide area networks, or WANs, are networks that span large geographic regions to interconnect locations across countries and continents. There are several broad categories of wide area networks, and I'll talk about 3 of these categories. The first category consists of ISP wide area networks. These networks are built and operated by internet service providers like Comcast and AT&T. The second category consists of cloud WANs that are built to provide dedicated connectivity between data centers of cloud providers. In contrast with ISP and cloud WANs, there is an emerging category of wide area networks called non-terrestrial networks. Some infrastructure of non-terrestrial networks is above the ground, located in different parts of the Earth's atmosphere. The Loon network, Starlink are popular examples of non-terrestrial wide area networks. But all of these different types of WANs have something in common. They all need high infrastructural investment. This includes billions of dollars of capital expenses on electrical and optical equipment, fiber connectivity, etc. Moreover, managing these WANs can cost millions of dollars annually. So due to how important and expensive they are, it is crucial to operate wide area networks efficiently. Networking researchers and practitioners have developed several mechanisms to operate WANs efficiently. I'll focus on a subset of these mechanisms that are a recurring theme in the papers that will be presented in the wide area networking session. First, WANs have leveraged software-defined networking, or SDN techniques, to manage and control the network. In the SDN paradigm, the control plane of the network is decoupled from the data plane, allowing operators to program the control plane independent of the hardware that's responsible for forwarding traffic. Second, operators of these WANs proactively handle network events like link failures and congestion to prevent degradation of service. And third, operators have come up with intelligent ways to share common network resources like link capacities. With that, let's take a look at the 5 papers that will be presented in the WAN session at SIGCOMM'. I'm going to put these papers in the context of the 3 themes that we just discussed. So the first paper of the session is STIPSy. In this work, the authors develop a statistical classification technique to predict where does the traffic toward a destination prefix enter a WAN. By accurately predicting the ingress interface into the WAN for a flow, STIPSy informs the network operator with important information needed in the event of congestion on ingress interfaces. Using this information, the WAN operator can withdraw and re-advertise prefixes to balance the utilization of WAN ingress interfaces. This work builds on the broad themes B and C of proactively managing link congestion and intelligently sharing network resources. The second paper of the session is Network Entitlement, Contract-Based Network Sharing with Agility and SLO Guarantees. This work defines the concept of entitlement contracts between services using the WAN and the WAN itself. Entitlement contracts allow services to reserve bandwidth on the network for long durations on the order of months. The authors propose bandwidth forecasting mechanisms to establish these entitlement contracts and enforce them at runtime. This work builds on ideas B and C by proactively managing the possibility of congestion due to misbehaving services using an unfair share of network bandwidth. The third paper of the session is SDN in the stratosphere, Loon's aerospace mesh network. This paper discusses the author's experience of operating the Loon network for several years. The Loon network provided 4G LTE connectivity to regions underserved by traditional telco operators. The base stations of the Loon network were carried by high-altitude balloons, and Loon implemented directional point-to-point radio links from the base stations for backhaul connectivity. The Loon network built a centralized SDN controller that predictively responded to changes in the environment of the balloons. This work builds on the ideas A and B by using SDN for network management and proactive response to network events caused by the highly dynamic environment of the Loon balloons. The fourth paper of the session is Software-Defined Network Assimilation. This paper solves a key problem faced by wide area networks that leverage the SDN paradigm. As a software-defined network grows in size, it must add or assimilate new network switches and routers into the operating fleet of devices. Doing this manually is hard because of the mismatch between the configuration model of the network hardware and that of the centralized SDN controller. Authors of this work propose techniques to perform assimilation of new networking hardware automatically by parsing manuals of network devices to build correct device configuration models. Then they use deep learning to map the device configuration model to the SDN controller's unified model. This work builds on the idea A by making assimilation of network devices in software-defined networks scalable and automatic. And finally, the fifth paper of the session is a case for stateless mobile core network functions in space. This work argues that it is beneficial to move the mobile core of access networks to satellites. They find that doing this today is challenging due to the dynamic nature of satellite networks. The authors find that the frequent loss of connections with the mobile core in space can be dealt with by making the mobile core stateless. They discuss developing such an orbital core for mobile access networks by splitting state of the core network between satellites and terrestrial user endpoints. So here's a summary of the work that will be presented in the WANS session at SIGCOMM'. Thanks for listening, and please consider attending this exciting session to learn more about the author's work on wide area networks.